Hi, and welcome to the Frog Pond School of Design, where we like to talk about things related to architecture. Today, I want to talk about something more related to construction. You see, the county highway department decided to replace a bridge just up the road from us here. In fact, we're so close to it that the barricades are literally right at the end of my driveway. So we've got this project going on just right off our property here. And the foundations for this bridge are being done with what they call piles, driving structural elements down into the ground to become the foundation of the bridge. So we were treated for a matter of weeks to this boom, boom, every 2 seconds, boom, boom. And of course, they had to go a lot deeper than they anticipated going, so this went on for quite a while. Well, pilings are an interesting thing. They can be made out of a variety of materials. There are even wood pilings. Mostly steel is the most common, and sometimes in a tubular shape, whether it's rectangular or circular. And if that's the case, typically they'll fill those with concrete when they're finished. And they're also what they call sheet pilings, which are they have some width to them and they're shaped at the end so they kind of interlock, and they can actually form an embankment, either to hold a bank back permanently, or during construction they can create a well with these things so it's safe for workmen to be down in there. I did one of these posts on the construction of the Brooklyn Bridge, where they used caissons instead of piles, and that presented all kinds of problems. So this is much safer. They can go down and create a space, de-water it if necessary, and give the workmen a safe place to work so that they know the sides aren't going to cave in and they're not underwater like they are with caissons or something. So the piles are very effective in that sense. It's just that in this case, they had to do a lot more pounding than they thought. You see, a piling gets its structural strength by either encountering hard enough soil that it won't go down any farther, or by building up, I suppose, by building up friction on the sides of that pile as it goes down. So you keep driving and you know you're deep enough when it quits going down more than a certain dimension with each blow. So it's an interesting thing to kind of work with structurally. They can be beam shapes as well. I said steel. In the case of our bridge, they are actually the foundation for the bridge. They're not an embankment or something like that. Pilings go back like 5,000 years. There are records of using something that would be considered a version of the piling. In the early days, they actually used animals and pulleys to pull this weight up, and then they'd drop it, and then have the animals pull it again and drop it. Of course, today, that's all done hydraulically, and interestingly enough, there's a newer type of pile driver that uses vibration. And all that really is doing is taking this boom, boom, and doing a lot more blows a lot closer together, because it's going to take the same amount of energy to drive that pile down so far as in either way of doing it. There are some drawbacks. I worked in an area once where we actually had a letter on file saying that we shouldn't drive piles within a certain distance because the soil type in that area was such that it would transmit the vibrations from the pile driving significant distances and actually threaten existing structures in the area. So there are precautions you have to take when you're going to use these things, but they're an effective tool. They do a lot of different things. It seems kind of low tech, but it's effective. So thanks for joining us today at the Frog Pond School of Design. I look forward to seeing you hanging around the pond again real soon.